Hello everyone, welcome to Python Dev channel. In today's video, we're going to dive into the world of web scraping and job hunting with Python. Specifically, we'll be using Python to scrape job listings from LinkedIn, all while dodging LinkedIn's security measures by using proxies and making our search super precise by filtering job descriptions by language. Proxies are crucial because they help us avoid IP blocking, which LinkedIn often employs to deter web scraping. By the end of this video, you'll have a Python script that can automate your job search on LinkedIn. So let's jump right into the code. First of all, we need to import several Python libraries and modules that are used in the script. The requests library is used for sending HTTP requests to web pages. In this script, it is primarily used for making GET requests to LinkedIn's job search pages. The time module provides various time-related functions. In this script, it's used for introducing pauses or delays in the execution of the code. This is useful to prevent overloading the website with requests and to simulate more human-like behavior. The Beautiful Soup is a library for parsing HTML and XML documents. In the script, Beautiful Soup is used to parse the HTML content of web pages fetched using the requests library. This allows the code to extract specific information from the web pages, such as job descriptions. Pandas is a popular data manipulation library. In this code, it is used to read data from a CSV file and convert it into a dictionary for further processing. The CSV file contains information about proxy servers. URL-lib module is used for URL manipulation. In this script, it's used to encode the search query so that it can be included in a URL for searching LinkedIn jobs. SQLite 3 module provides a way to interact with SQLite databases in Python. The script uses SQLite to store information about job listings. Multiprocessing pool and CPU count modules are used for implementing multiprocessing. The pool class is used to parallelize the process of scraping job listings by distributing the work across multiple CPU cores. CPU count is used to determine the number of CPU cores available on the system. The random module is used for generating random numbers and making random choices. In the code, it's used to randomly select a proxy from the list of proxies to be used for each web request. LangDetect library is used for language detection. It helps identify the language of job descriptions extracted from web pages. These imported libraries and modules provide essential functionality for the web scraping and job search automation task that the script performs. They help with making HTTP requests, parsing web pages, data manipulation, database interactions, and other tasks required for the job search process. To scrape LinkedIn effectively, we must use proxies. Proxies are like a mask for our requests, allowing us to access the data without raising suspicion. Let's see how we set up our proxies. In the code, we start by importing a list of proxies from a CSV file. These proxies include information like IP addresses, ports, usernames, and passwords. This data will help us route our requests through different IP addresses, making it challenging for LinkedIn to identify us as scrapers. Now, before we can scrape job postings, we need to define what we're looking for. We'll construct a complex search query for LinkedIn jobs. This search query will be encoded for use in the URL, making it easier to send our search requests. We're going to filter out job listings that contain specific keywords and phrases we're not interested in. The URL building function in our code constructs a URL based on parameters like the search query, location, and experience level. These parameters are crucial because they help us narrow down our search and target specific job listings on LinkedIn. To keep track of the job listings we find, we'll set up an SQLite database. Let's take a moment to understand how our database is set up for this purpose. Our code uses SQLite, a lightweight relational database, to create and manage a database where job data will be stored. This database will store valuable information about each job, including the job title, language, description, whether it offers easy apply, and the required seniority level. Now the real magic begins. We'll define a function that scrapes job descriptions and job details from individual job postings. This function goes to LinkedIn, retrieves all necessary data, and even checks the language of each job. Our main function is the orchestrator of this entire scraping operation. We'll use the requests library to perform job searches on LinkedIn for different experience levels. The main function utilizes the LinkedIn job search URL we built earlier. This function will scrape multiple pages of job listings and we'll be looping through them, collecting job IDs as we go. As we scrape job listings, we'll also keep an eye on the database. We'll make sure not to insert duplicate job listings. This way we can collect unique job opportunities. Now that we understand how the code works, let's see it in action. We'll run the code with different experience levels and demonstrate how it collects job data. As you can see, we execute the code with various experience levels and observe how it efficiently collects job data. Before we wrap up, it's crucial to talk about ethics. Web scraping is a powerful tool, but with great power comes great responsibility. Web scraping can be a double-edged sword. While it empowers us to gather valuable data, it's essential to use this knowledge responsibly. Let's respect websites' terms of service. In today's video, we took a deep dive into the world of web scraping LinkedIn job postings with Python and Proxies. We discussed the code, the setup of our database, and the scraping process. Remember, knowledge is power, but using it responsibly is crucial. In summary, we learned how to scrape LinkedIn job data while respecting ethical and legal boundaries. If you found this video helpful, please show your support by liking, subscribing to our channel and hitting the notification bell. If you have any questions or ideas for future videos, please leave them in the comments below. Until next time, happy coding!